Yes, you are most welcome once again to my YouTube channel. It is still your tutor Peter Ekaja, and in this video, I'm going to be taking you through the very last subtopic of partial fractions, and particularly looking at improper fractions. The very first important thing is to know what an improper fraction is considered to be. Now, an improper fraction is one whose numerator is of degree equal to or greater than that of the denominator. What do I mean by this? I mean, in this case, if our fraction is in terms of x, then the highest power of x in the numerator must either be equal or greater than the highest power of x in the denominator for it to qualify to be an improper fraction. Otherwise, then it is a proper fraction. Now, to deal with such a case, we shall first divide the numerator by the denominator, but in this case, using long division. I have an example here that says express x cubed plus 2x squared minus 10x plus 9 out of x squared minus 9 into a quotient and a proper fraction, hence find the integral of the same expression. Let's look at how we go about with this question. So in our solution, we shall begin by saying we begin with long division. So I draw a long division sign. I have the numerator as x cubed plus 2x squared minus 10x plus 9. I am dividing it by x squared minus 9. So you begin with the term with the highest power, x cubed divided by x squared. That gives us x. The same x you obtain multiplied by x squared. That gives us x cubed. X by negative 9. That will give us negative 9x. But I would prefer for easy subtraction. You realize we don't have any x squared. Then finally I write minus 9x. From here, you first subtract. So x cubed minus x cubed is going to give us 0. 2x squared minus 0x squared gives us 2x squared. And then minus 10x minus 9x. That is going to be minus 10x plus 9x, which is minus x. And then definitely we carry on with the 9. So we shall say plus 9. Then we again check whether we can go for another division. 2x squared divided by x squared. That will give us 2. And then the very 2 times x squared. That will give us 2x squared. 2 times negative 9 is negative 18. We don't have x, so I can again say plus 0x and then minus 18. So when you subtract, 2x squared minus 2x squared is 0. Negative x minus 0x, that will give us negative x. And then 9 minus 18, that's going to be plus 27. So you realize now we cannot go for division again because we cannot get negative x and divide by x squared. So we now write a conclusion that actually our fraction, which is x cubed plus 2x squared minus 10x plus 9 divided by x squared minus 9 is actually going to be equal. We first write the quotient x plus 2 and then plus our remainder that we had, which is going to be 27. I've just rearranged it, but divided by our x squared minus 9. Now, the quotient, we already have it. So what we do is now we focus on this fraction that we have obtained. This is now a proper fraction. And then we ask ourselves, in which type does it fall under? Clearly, we can say that 27 minus x out of x squared minus 9 is as good as saying 27 minus x divided by x plus 3 into brackets x minus 3, which is the difference of two squares. And our intention is to let the whole of this to be a out of x plus 3 plus b out of x minus 3. Why? Because this now falls under type 1, where we have a denominator with linear factors, or with only linear factors. So from there, we look for the value of a and b. That means we shall have 27 minus x is equals to a into brackets x minus 3 plus b into brackets x plus 3. From there, we can equate each of the factors to 0 at a time. And then when you do so, definitely we realize that one of the values will be 3. When you put 3 on the left-hand side, you will have 24. On the right-hand side, you will have 6b. That means the value of b in this case becomes 24 divided by 6. And 24 divided by 6 is going to be 4. Then we can also put another value, which can be x equals to negative 3. I've got it by equating x plus 3 to 0. When you put it on the left-hand side, you will realize that will be 27 minus 3, that's 30. And on the right-hand side, you will have a into negative 6. That means the value of a now becomes negative 5. From there, we can clearly see that now our 27 minus x divided by x plus 3 into brackets x minus 3 is actually equal to a, which is negative 5 divided by x plus 3, and then plus b, which is 4 divided by x minus 3. So we have expressed this as a partial fraction now. We now come and make a conclusion that from where we started from, which was x cubed, our x cubed now, plus 2x squared minus 10x plus 9, all this divided by x squared minus 9 is actually as good as the quotient we had already got earlier on, and then minus 5 out of x plus 3 plus 4 out of x minus 3. So from there now, we can conclude that integral of x cubed plus 2x squared minus 10x plus 9 divided by x squared minus 9 with respect to x is equals to integral of x plus 2 with respect to x minus integral of 5 out of x plus 3 with respect to x, and then plus integral of 4 out of x minus 3 with respect to x. From there, we can now say the final answer here would be x squared out of 2. That's when you integrate x. When you integrate 2, you get 2x. And then we come to the next integral, 5 out of x plus 3, that will be 5 natural log of x plus 3. And then 4 out of x minus 3, when you integrate it, you shall have 4 natural log of x minus 3. We can't forget the constant of integration, and that becomes our answer. So in conclusion, we are trying to say that when you're handling improper fractions, you first begin by long division. After obtaining the quotient, you first write the quotient, and then write the proper fraction. After writing the proper fraction, you go on and break it down to partial fractions, depending on which type it falls under. And then after that, you generalize and make a conclusion. In case they ask you to integrate like they did in this example, you do it easily. I think with this, I only want to emphasize one thing, that never should you forget that before you do any number of partial fractions, check whether it's proper or improper. If it is proper, then proceed normally depending on the type you've recognized. If it is not proper, then first go for long division, have the quotient obtained together with the proper fraction, which you can now handle as we have done in this video. I thank you so much and I want to wish you the best. Subscribe, turn on the notification button so that in the next video you will be notified immediately I post it. And then share to the outside community out there for everyone to benefit from these services. I thank you so much. See you in our next video. And guess what? In our next video, we shall be talking about further integration, and in particular, integration by parts. The only thing I can now show you in just a second is your simple exercise that you will do for purposes of perfecting on what we're doing. And there it is, a very simple one. Try it out in case of any issues. Always get in touch with me with the contacts that you saw right away at the start of this video. See you in the next tutorial. Please, bye bye.